Mr. Mrs. Chair. Let me try to launch the presentation, if I'm able to. Okay. Well, while preparing this presentation and talking with people in my division, we try to talk about the sense of what we are doing. And so what we will see now is just a snapshot of some of our activity. But also we try not to forget the sensibility of what we put into the activity. So it's just a fraction of the activity, but also we have a social responsibility in what we do every day. We talk about, say, boundary conditions in a way. Let me say, if you take a spring and you pull a spring and you let it go, then it will go back into position. But if you pull it farther and farther, at the end, it suddenly won't. So just you have a piece of wire. So my point is that what happened to the Earth system if you overstretch the system like an spring? So that's our responsibility from the point of view. Again, I'm just talking about boundary condition because this is the place in which depend point for mathematicians in some way. But again, talking about boundary condition, we know that by 2050 there will be 9 billion people to feed on the Earth. So it's, how can we do that? And from that point of view and the environment, we set the boundary condition for our future, basically. And within the environmental study, certainly the way to monitor the environment and the way to monitor meteorology and climate will play a major role in the future. So we just have a snapshot about meteorology, but just have a look at the whole picture of what we are dealing about. Meteorology and metrology, so they just differ from a couple of vowels, but actually they are two fundamental science. Meteorology, it's a really interdisciplinary science, looking at the scientific study of the atmosphere. Metrology is what we already discussed today, including it's the base of the measurement science. They both have a long history. They are two separate communities, but yet they have many points in common. So they both were founded about more than a century ago. A couple of years of difference between the two. They both have organized, they are several organizations, they are global organizations in such a way that they need to work a global network of institutions in order to back up their activity. And by chance, unfortunate case, just a few years ago, they met in such a way that the WMO, which is the World Meteorology Organization, comes to BIPM in Paris, and they signed together what we call a mutual recognition agreement, which is the base of our activity, basically. So it's the fundamental document that say, okay, metrology is organized in that way, and there are a number of steps to disseminate our activity around at the global scale, and WMO agreed to be part of this game, basically. So all the web activity are under the INRIM umbrella. And this is particularly important because to have a closer and tighter liaison and cooperation between the two communities. Because if you just look at some of these important data, such as the global warming, and then you look in perspective, so you have a huge number of data over centuries, but if you have a closer look and you see, okay, what are the quality of the data along the history, then you see you can pick up uncertainty bars for each of these data, and you can see what are the actual uncertainty bars for each of these. Well, of course, this does not mean that there was no such global warming. It just simply means that if you, at the WMO level, they are looking for changes. So they are able to look at small changes, even if the absolute accuracy is larger. So that's absolutely true. But if you'd like to tie all these measurements to our SI system, then you need to also talk about the accuracy of each individual measurement, of course. And because of that, we decided at the European level to set up a program. So we have a large research program in metrology, agreed among all the European partners. And so we set up one of these projects. It's a large project. It's a project with 18 European partners and a number of collaborators. But basically, just to give you some figure about this project, which is a project to talk about which investigate some of the key variables for the meteorological activity, for the meteorological monitoring. It's a large project with several partners, a huge number of collaborators, and a huge effort in the work. So it's about 37 man years in terms of effort for this large consortium. So the question is, okay, we set up a large consortium. Why we need so large consortium? Well, I could say that we know that the world is divided into countries, but of course the climate has no borders, and also the expertise of the climate require no borders. So from that point of view, we would say that climate data there must be reliable, of course, and to have reliable data, this is geographically equivalent relevant. So any part of the world is the same weight in terms of the impact on the global climate. And the European metrology decided to lead this large-scale project and to work on what I will show you at least partially. What is the rationale of the project? Well, the rationale is to bring the traceability where it is needed, so into the field. So meteorology is a field job, so we need to bring the traceability to the SI unit directly into the field. What you can see here is the way that we generally do this job. So we have calibration into the laboratory using fixed point. We have some calibration at the lower level using comparison technique, and then step by step, then we go to the field for calibration, for providing the traceability of the meteor station, weather station. But there is also another way to do it. So basically, you can use another way, another road to bring into the field some kind of portable calibration system in order to do a in-situ calibration of your sensors in the field. So one of the activities to be performed to this project, again, it's a large project, so we made a lot of things. I'm just focusing on this fraction of our activity, is to develop a system for simultaneous calibration of temperature, pressure, and humidity. And also, the system is working in such a way that we can also make individual calibration and check what are the influence quantities of the other quantities, so we can make this cross-correlation job. We made a number of these prototypes. Some of them are too big to be really transported. And some of them, at the end, we decided to build a system which was less than 30 kilograms in weight. I will show you why. Well, in August last year, one of these portable systems flew to Kathmandu, from Turin to Kathmandu, and we decided to bring the calibration system on top of the Everest pyramid. And because part of his job is in the field, or in the track, basically, so we had a number of Sherpa bringing on their shoulder all these instruments. So the maximum weight to be carried by Sherpa is 30 kilograms. So we built a system which is less than 30 kilograms to be transported. So this is one of the base stations that 13th of September, some of our colleagues were setting up their camp. Then, step by step, every day they climb up along the mountain, and in 4 days of March, they reach the top of the pyramid, which is an international project led by Italy, together with the K2, Everest, and CNR committee. They set up this small calibration lab in this area. There was of course a number of weather stations in different altitude, and the idea of the lab is to have a permanent high altitude small metrology lab in the pyramid. They make training of the personnel of the working in the pyramid, and they do some real calibration. And then at the end they were really happy, and they made this picture about their work on the Meteorology project. None of these things at the European level, they have quite a large impact. And let me just credit Andrea McLaughlin, our colleagues in my division, which is the project leader of this project. And the Meteorology project won recently in 2013 the Impact Prize for Europe because of the impact of this activity. So this was something that we do above 5,000 meters of altitude. We also, just to be connection with the last talk, we also had as an outreach of our activity, we carried out some research in the agrometeorology. So again, we share the same problem with our colleagues in Florence. And again, using our facility, we try to put sensor into the field. This time, the sensors are calibrated, both in the lab and into the field, just to show that the cost is affordable in some way. So you can bring the traceability to the field with affordable cost. So it's a good message from that point of view. It's not that expensive. Again, let me say that we have some colleagues that like the extremes. So the next step of our activity is to set up a small meteorological lab in the polar circle. We have this year, basically next month, one of those transportable chamber, calibration chamber, will go. Actually, they already are shipped to this Svalbard Island in Mialezu. It's a small research village into the Svalbard, which are within the polar circle. And 3 researchers will go there at the polar base next month to perform calibration of instruments used for meteorological observation and monitoring on that base, on this research base. And the idea of this preliminary investigation is to prepare the basis and to make a feasibility study in order to set up a small Italian metrology lab in the polar circle. So what next? Well, again, in talking around and about climate and meteorology, we certainly have to talk about the global climate observing project. GCOS is the global climate observing system set up by the United Nations. GCOS defined a number of what they call essential climate variables. There are 50 variables. Technically and economically, these ACV are feasible for systematic observation, and most of them are really critical for environmental and climate monitoring. So there is a need of cooperation between countries and between intergovernmental organizations, both to have, say, a current, to ensure a current high quality of the data, and also especially for climate study, it's quite really important to have to assess the quality of the historical observation and the historical time series, because they are part of the game, of course. What next? So we decided to bid for another project, European project. This time the project is called Metrology for Essential Climate Variable. It's a new project that will start next October. It will deal with the three main aspects of climate monitoring: air measurement, radiosonde calibration, airborne traceability of humidity and temperature, water measurement, especially oceanographic and deep sea measurement, and land measurement, soil moisture, permafrost in the polar circle, air humidity, air temperature and humidity. So that is, let's say, just a snapshot, but in some ways part of our contribution to what is known to be the Horizon 2020 Grand Challenges on environment. One of the grand challenges is, of course, to work towards a safer and sustainable environment. And also to include within this activity the climate change monitoring. And what is identified as an important aspect for in order to cope with this climate change monitoring is to, of course, improve our monitoring qualities, to improve the quality of the data, which means for us to ensure the traceability to the SI unit of our measurement, and to have a better understanding of the properties of the atmosphere. Thank you for your attention.